Okay, we are going to. I'm gonna try this out right now. Predicting Shakespeare with Cloud TPU and Keras. Okay, it's connected using Google Colab Research. I got this from somebody I found on Twitter. I think he's a Japanese researcher. Um, okay, I'm just gonna make sure. Let's see here. Is it using TPU? Change runtime tab. TPU. Oh, awesome. Okay. All right. So this example is using TensorFlow.Keras to build a language model and train it on Google Cloud TPU. This language model predicts the next character of text given the text so far. The trained model can generate new snippets of text that read in a similar style to the text training data. We'll train the model on the combined works of William Shakespeare, then use it to compose a play in the style of the great bard. Okay, I'm not really good with Shakespeare, so let's see how it works. Okay. Love that let me know dumps like her bear joy face with her day today. The spirits roared with shames within his powers, with tied up remedies landing with occasion. A loud of Lancaster, stab in me, upon my sword forever, Agripor his days let me free. Stop it of that word, be so at lair. When I did profess the hour stranger for my life, when I did sing to be cried how for aught. Some beds with 6 chest senses prove burning, but he perforces sin in her eyes so fast, and I have no idea what I just read. Anyway, it seems to be like about like love, but like spirits, but uh vengeance probably, but passion. Okay. Okay. To enable TPU, change runtime. I did that. Download data. Download the complete works of. Okay, I'm just gonna make this so simple. There we go. It's better like that. Probably I can make it bigger. Boom. There you go. Now it's better. Okay. Okay, so we downloaded data from the complete work of William Shakespeare as a single text file from Project Gutenberg. We'll use snippets from this file as the training data for the model. The target snippet is offset by 1 character. Okay, okay, let's do that. Okay, we are downloading the single text file, which is part of the complete work of William Shakespeare. Okay, done. And then we're gonna next we are building the data generator. So we're gonna import numpy, np import 6 TensorFlow STS, import time, import OS, and then this address identify the TPU will use the configuring TensorFlow. So TPU dash worker equals to grpc slash plus os dot invite call up TPU address Shakespeare text equals to content Shakespeare text. Let's see. Okay, so because it's saving it over here at the Shakespeare .txt. Okay, so now we're it's putting it on this variable basically. And then tflogging.set dash verbosity parenthesis tf.logging.info define transform. Okay, so output nd np.asarray or c in text if path2 is not none, output the path2 output np concatenate np zeros. I think this is just a pre-processing the the data, and then define training generator. Okay, this one is a generator yields source and target array for training with tf.gval, tf logging.info input text. I'm so not familiar with this thing. While true, offset and be random. Our model uses sparse cross-entropy loss, but Keras requires labels to have the same rank as the input logits. We add an empty vinyl dimension to account for this. Yield NP is for ATX in offset NPN. Sim.next training generator. Okay. All right. Let's run this one. So building a data generator. Okay. So now project underboard the complete works of William Shakespeare array. Okay. Now we're building the model. The model is defined as a only two layer. Okay. Forward LSTM, long short-term memory, with two changes from the tf.keras standard LSTM definition. Define the input shape of our model which satisfy the XLA compiler static shape requirement. Use tf.train.optimizer instead of a standard Keras optimizer. Use tf.train optimizer. Keras optimizer support is still experimental. Okay. Embedding dimension is 512. Define LSM dash models. Sequence length is 100. Bed size none. Stateful true. Language model predict the next word given the current word. Source tf_keras.input. Name seed shape. Buts. Bed size. Yeah. Embedding tf.keras layers. Embedding input dimension 256. Output dimensions embedding /dim. So let's have TM1, the first layer is tf.keras layer SLTM embedding dim. Okay, stateful equals to stateful, return sequences equals to true embedding. The second layer is okay, tf_keras LSTM-1. What's the difference here? The first and the second layer. Not sure. And then predictor character tf.keras layer time distributed tf.keras.layers.dense 256. Activation softmax. Okay. So it's what is that? A probability model tf.keras model input output model.compile optimizer equals to tf.train rms prop optimizer learning rate 0.01 sparse categorical and the cross center of v matrix sparse categorical accuracy return model. Okay, so it's defining the model. Boom. Now we are training the model. tf contribute.tpu keras to TPU model function converts a tf keras model to an equivalent TPU version. When used, the standard Keras methods to train, fit, predict, and evaluate. Okay, tf keras.keras.backend.clear session training model equals to LSTM model sequence length 100 bed size 128 stateful false TPU model tf.contribute.tpu.keras TPU model training model. This is way over my head. I'm just reading this. TPU model.fit. Okay, so I guess this is the instruction to using TPU dash model fit generator and using epoch 100. Okay, bed size 1024. And then we're saving the weight at the temporary folder called part.h5. Okay, let's run that. Let's see how long is this. Number TPU cores 8, TPU workers 1, TPU cores per worker 8. Hmm. It's kind of a little different from the GPU training session. It doesn't give you like those like percentage. Oh, now it gives you. Okay. The loss, what? Sparse categorical accuracy. Okay, so there's 100. We're using 10 epoch, is it? Yeah, 10 epoch. And then the steps per epoch is 100. Okay. Hmm. This is new. Steps per epoch. Okay. The loss is decreasing. Accuracy is getting higher. Epoch 4. The loss seems to be decreasing. It's going to be 1.5. This is quite significant. I mean, the accuracy is from 18%. Is that 18? And then 20, and then 40, and then 56%. And I think it's going to be 60%. So this thing is basically trying to predict now it's basically training, right? Training all those Shakespeare's like sentences, right? Um so this thing like love that let me know dumps like her Burjoy face with her today. So this language model predicts the next character of text given the text so far. Okay. So the model will predict the next character of text in a Shakespearean manner. The trained model can generate new snippets of text that read in a similar style to the text training data. Okay. We'll train the model in the combine. Okay. It doesn't say like how many words. Does it say? Or is this the words? This one 500 um is it 5 million, 5.8 million or 5.6 million? 5.6 million texts or words. Okay. What is the label for this? That is the one I'm confused. This is a supervised, right? I mean, it's part of LSTM. It's part of recurrent neural network. I think it's a time sequence based prediction. Um, yeah, I don't know. I mean, you have where's the training data? Is there like a training? There's no such thing as training label. I guess this is way over my head. Okay. My guess is it's still like supervised learning. It's just the bed size is the same. I don't even sequence len. Probably it's every 100 words. It's just like something that's just ordinary at the LSTM model. Um, is it already like included? The label is already like part of it. You don't have to specify it. I don't know. Okay, let's see if it's done. I think it's done. Okay, okay, so it's done. It seems to be only like 65%, 64% with a loss of 1.1. Okay. Um, so it's not really high. I don't know. Um, and it's already putting all the weights into BART.h5. Okay. Make prediction with the model. Okay, now we use the model to predict. Use the trained model to make prediction and generate your own Shakespeare play. Start the model off with a seed sentence, then generate 250 characters from it. Okay. Oh, we'll make five predictions from the initial seed. Okay. So you just start out with a seed sentence. I don't know what does it mean by seed sentence. Okay, so you have bet size 5, prediction length 250. You want to predict the next 250 characters with a seed sentence. Keras requires the bet size be specified ahead of time for stateful models. We use a sequence length of 1 as we will be feeding in one character at a time and predicting the next character. Predict Prediction model equals LSTM model in parentheses sequence length is 1. Bet size equals to bet size, which is 5. Stateful true. I'm not sure what does that mean. I need to do my homework about this. Prediction model dot load weights. Okay, so you're loading the weights um, because you're using already a pre-trained. We just trained the model. We're gonna load the weights, and then we set the model with our initial string, copied bet size times sit tag. Okay, so this is the okay, so this is a sit text. Looks it not like the king. Verily, we must go. Okay, and then based on this sentence, just this one sentence, um, the model should spit out 250 text or next characters, which is mimicking the Shakespearean style. Okay, sit equals transform sit text. Sit equals np dot repeat np expand image bed size. First, run the seed forward to prime the state of the model. Prediction model dot reset states for I in the Netherlands seed minus one. Prediction model dot predict seed. Now we can accumulate predictions. Prediction equals to seed over I. Sample for output, blah blah blah. For I in the range bed size. Print generated, generate join character. Okay, for CNP. Generated text too short. Okay, let's do this. This is so exciting. So now we are trying to. Oh, there you go. Prediction 0. I thought it's 250 character. So okay, so just going back. So we feed it with this string. Okay, this is the seed text. Looks it's it not like the king. Verily we must go, and then it spits out for prediction 0. Brook for I, so please your majesty for Kafia, let Desdemona forever and so on. And being farewell to be gone, every good king, and still this to marrying it. We are the shoulder in eyes and make them best. Sicko. And then there's prediction 1. No more false stuff. Good morrow to Sir Evis my now. Great Hector and others, or being too patient behind me. Queen, but soft not. Suppose Somos, my lord, I marvel to be frail and rescue. Prediction 2. Prediction 3. Oh, wow. And then there's prediction 4. Wow. There's 4 predictions. Actually 5, because it starts from prediction 0. Oh wow. So you can generate like five predictions. Oh, so probably this is the bet size five? Is that that? And 250 characters? Is this 250 characters? Like one, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh wait, character. Wait, characters. Okay. You want to count it? Like one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 45, 46, 47, 48, 49, 50. I don't think this is 250 characters. That's weird. Anyway, yeah, so bet size I think is the number. So if we like put like 10, then it's gonna make 10 predictions. Let's see. 250 characters. Oh, it's different. Oh my gosh. Yeah. Okay. Let's see. My name is Danny. How about if we do that? Can we do that? This is fun. It said, my name is Danny, and then where is that? Uh, Verily, we must go. Okay. To Adrian, Duke, why should that so long monster body princess dot be is the very jaded myth? Oh my gosh. How about if it's like, hello? How about if it's just like so simple? It's so simple. My name is Danny. Hello. That's the seat. Oh, seat. Still too. Casting this. I have no idea what's going on. How about if it's just say hello? Hello? Like that. I'm messing up with this Shakespeare. Let's see what's gonna do now. Yeah, come on, shouldn't be too difficult because the seat text only, hello. Good night, son. His place emitted at color of two of the antenna of color or word firstborn. Well, bless Lord, I'm gone. Gone. Okay, so I guess it's still complicated, even though you put like uh something that what if you just put like this? Like what happened? If if the syntax is like none. Oh, it doesn't work. How about if it's just a space like that? Can you still do it? I'm just gonna say hi. Well, I said hello earlier. It was working. Now it's just a space. So it's only one character basically. Um, I don't know. Do you think it will work? I think it will work. As long as you have one character, it doesn't matter whether it's this is like space bar or a real character. Um, See, it will work. Oh my gosh. Honorably treason, welcome, good lord. The content of the time of state, whose opposition that the good Volscian Romans that all is drug to spill, all to the eighth borough. Okay, I'm just gonna put like, okay, to be or not to be or not to be, that is the question. Okay, I'm just gonna put like 5. Okay, all right, and then probably like 150. Just make it make it shorter. What does it say? Keras requires the best size will be specified for stateful modules. Okay. Sequence length of 1 as we will be feeding in one character at a time and breathing in the next character. Okay. Okay. Come on. Generate the text too short. Hmm. I think I'm gonna have to brush up a little bit of my Python thing. Oh, here we go. So it's shorter, right? So Brilliant Zero. N. Habers to his purchase, the art for thy ways I not come. Then have the courtesies of Buckingham do God spoke spec our blood regards. Oh my gosh. I don't know what you're talking about. Prediction 2. And in the fun or two, and ears so much having offended, things that God enforce peace, Valentine, when hences unto shall we be. Okay, enough of this. My brain is frying. It's working, thank you. The TPU is working too. All right. I don't know if it will be a much help to you, but well, I learned something. I learned something that I have to learn a lot. Until next time, see you guys. Peace out.